Welcome everyone, welcome to our another webinar with award-winning author and international presenter Dr. Paul Swan, Talking Maths. Today we're going to look at pattern blocks. We're going to do tips and tricks and games. So we're going to look at fractions, multiplication, division, geometric ideas like symmetry. Just a reminder, if you don't have any pattern blocks in front of you, you can go to drpaulswan.com.au/webinar and you can download. You've got a few minutes now, you can download and cut them out. You can also, there's a whole lot of sheets as well that you can follow along with the games that we're going to do today. During home learning this year, I've found pattern blocks really helpful during maths because I was multiple ages. So I was entertaining a younger child and an older child trying to teach maths. And what we did is fractions with the older child, and the younger child just did some patterns or 2D, 3D designs. And we'd just talk about the colours and the shapes. So I found these a very valuable tool in the last couple of months. But before we hand over the screen to Dr. Paul Swan, I just want to mention a new collaboration that we have with Dr. Paul Swan, and it's a website which has all our maths manipulatives. It's also going to have the sheets and the videos with different mathematical language. It's going to talk about where it sits in the curriculums, different curriculums with videos, and it's mathsmaterials.com or math101.net. So please have a look and let us know your thoughts. Let's hand over to Dr. Paul Swan and his team. Thank you.
Thanks, Heather. Appreciate that. So we're just going to talk today about one piece of equipment, and that's why we thought we'd put it up in a slightly separate spot on the web for you. But essentially the piece of equipment we're talking about are called pattern blocks. And I just need to make a couple of distinctions because sometimes this bit of equipment gets mixed up with another piece. So I'll show you on our screen here exactly what the difference is. We're going to talk about pattern blocks today, but some people mix up with attribute blocks. So let me just show you what the difference. So you'll notice if we look down at the screen here, and you'll see there's some blocks showing. And they should come up here. You'll spot them on the screen. Yeah, out of here. Okay, and in that set of blocks, you'll notice that there's different sorts. So in this case here, we have this sort here, but we have these ones, and they're known as attribute blocks, these ones in the packet. Now, they differ from these ones in a couple of ways. The pieces in here come in different sizes and different shapes and different thicknesses. So you can see I have a small and a large one. Now these, you see the thicknesses, these are known as attribute blocks, and they're not what we're talking about today. But sometimes, as you can imagine, these get mixed up with these. So I'll just put those away because we're not talking about attribute blocks, but what we are talking about pattern blocks. In pattern blocks, the other reason people get a bit mixed up is some come in wooden form, and they have a thickness of about 10 millimeters, and some come here in 5 millimeter in plastic. We'll just use the 5 millimeter plastic ones today for the purpose of what we're about to do. And before we start, we should name the pieces just to get a feel for them. This one, we're going to refer to this flat surface as being a hexagon. Now, clearly, it's a hexagonal prism, but we're not just going to talk about the flat face that sits here. This one, the red piece, is called a trapezium. In the United States, that'd be called a trapezoid, and the definitions vary slightly. The blue piece often is called a diamond, but in fact, it's really a rhombus that sits here. Or another name for it would be quadrilateral because it's got 4 sides. The same with this. This could be called a quadrilateral. There's the square, and as I said, some children mix that up with they say, oh, this is a diamond. And I say, when did it stop being a square? Also a quadrilateral. There's also another piece here, and this one is a rhombus as well. Think about it as like a pushed over square because all the side lengths are the same. And the last piece here is a triangle. As we move up to school, I would rather the children refer to that as an equilateral triangle because all the sides are equal lengths. So we can do a lot with these blocks, but I thought we'd just start with some pretty simple material first and just play with a few ideas here. So let me give you one example. Heather referred to it already, but it could be as simple as this, and here's a sheet you're welcome to download it and print it out as well, which is simply about like a jigsaw essentially. So what we're doing here is we're fitting shapes into this jigsaw, so to speak. And in this case here, we might say, well, say this piece maybe fits about here. Now if that piece fits there, then maybe I'm going to put this piece here. Notice as I'm placing the pieces, what's happening is that I'm starting to see there, I've rotated. Sometimes I might turn a piece over, but I'm rotating in this point here. So we're informally learning some of the early geometry when we do this task. You can probably see that this piece probably fits in there, and yeah, it looks like it does. And this piece fits in here, and quite clearly this piece fits here. And just in this notion of fitting pieces in, we're doing a lot of geometry. And effectively, geometry at a primary school level is really about three things. It's about what it is, which is what we've been doing recently. We've just been naming the shapes. That's the what it is. The where it is, that's the location where it is, and then how it moves or changes. So in other words, this turning and sliding and flipping, those are, sometimes we call it flip, slide, turn, those sort of things. Now, when we do one of those puzzles like the cat, essentially children are learning a lot of spatial reasoning. They're placing the pieces down and so forth. But we want to make it just a little bit more than that. So while we're doing these essentially play activities, what I'm hoping to do is develop the language that comes from it. So if you have another look at this cat figure, we're going to look at one little change that we can make. And in fact, it's in the wording. It says, try to make the cat using the least blocks. Try making the cat using the most blocks. Well, if we're going to use the least blocks, we'd want to be taking these larger pieces, if possible, and trying to use them. And where possible, use less of these pieces. So we have, as much as possible, most of these pieces and use less of these green pieces. However, if we were trying to use the most blocks, we don't want to use the big pieces. We really want to use as many of these small pieces as we can, because it takes more small pieces to cover an area. And so we're learning some very informal measurement material when we start playing with that sort of idea. You can start to see that we're going to build it. And if you look carefully here, if I take this piece out, you'll see that about 6 of these fit on top. So for every one of the yellow hexagons, we could replace it with 6 of these green equilateral triangles. And so you start to see that if I was using the least blocks, I'd try to choose the larger ones that cover the most area. If I try to use the most blocks, I would choose the smaller ones. And so you get a bit of an idea here about, just from a simple idea, like making something, how we can now develop the mathematics. Now, just here's a thought. It's one thing for us to give you a picture that's already done, like the cat, but children are much more interested when they have the opportunity to make their own shape. So imagine that one child then made the shape, used the blocks to make it, traced around the outside, then took all the blocks away and said that is a bit of a challenge for another player. So children like to make their own challenges. And then we can make it a little bit more difficult, as I say, simply by asking which would take the most blocks. Could we use as many blocks as possible, or could we use the least number of blocks? And what they're learning there is, the larger the block, the less you'll need. The smaller the block, the more you'll need. A fundamental idea or area. So that's one aspect there. Now we can just make it a little bit harder. So for children getting a little bit more involved, we could change our picture a little bit. And I'll move us on to another example of that. And you can have a look at it. And this one here, we've just got 2 versions of a shape, and you'll see it, and you can download this as well to play with it. But basically, we're going to make this same thing, but we could use different blocks. So for example, here, you can probably see that we're in here, we're using the yellow hexagon, and then we might put in here the blue rhombus, and that's one way to make that. But are there other ways to make that? Well, we could use some other pieces. I wonder whether maybe this might work. And so we start using a little bit of thinking, oh, well, I wonder if that goes there. And then, well, I wonder if, and I'll put it in there and see how we go. Oh, we got one more piece that might go. And in here we can see. So even the idea that you can make the same shape but use different blocks is quite involved. And you probably already worked out that there are different blocks that I could substitute here because they have some relationship in terms of their size and so forth. So we're starting to get a feel for the versatility of these things called pattern blocks. So not only will they do the geometry that you want them to do, but now we can build a little bit further into some other ideas of mathematics in particular. So let me give you one example. We've already sort of alluded to it when I took the yellow hexagon and I put the other pieces on the top. Now, one part of mathematics is called problem solving. So we don't always want to give the children the answer straight up. We want them to think a little bit. So here's the question that I like to pose. And I'm just going to put on here, I'm just going to take one yellow hexagon, and you watch what we're going to do with the one yellow hexagon. So I've just put it on the screen here. You can have a look. So we should have one yellow hexagon showing. And then the question that we're going to ask is, so how many different ways could I cover the yellow hexagon? Now, that's a little bit of an open or loose question, but I let children play with that idea just a little bit. And so, for example, I could cover, if you look here, we could cover with two red trapeziums, and I'll just put them right next to it so you can see that. That's one way of covering. What I'd like to do is, if you've got the sheet, remember the sheet where we can have the one where we had all the printable ones. If you don't have some pattern blocks, one thing you might like to try just for the next 30 seconds or a minute or so is to think about all the different ways that you can cover a yellow hexagon with other pieces. I'll give you one more example. We don't have to use all the same type of piece. So in here, you can see that we've mixed up some pieces. So what I'm going to do is probably what I find very difficult to do, and that is to be quiet just for a moment and let you think and play with the pieces and try and work out how many different ways can we cover that yellow hexagon. So welcome back, and that was an eternity for me to be quiet for so long, but I'm just going to show you another sheet that we've made that may support you to do this. So we put a couple of examples there, and essentially we're looking at all the different ways that you can cover that yellow hexagon. Now, after a while, the children will work out that some things are repeats of others. There are some obvious ones here. So for example, we've already looked at the fact that 6 of these triangles, the green equilateral triangles, will fit on top, and so forth. So what we're doing is building a bit of a pattern here, but really what we're starting to build is the notion of area as covering, and then from that we're going to build into 2 other ideas. One is the idea of fractions, and we may even do a few tables as well. So let's just take the 3 obvious ones here, first of all. So if we take the red trapezium and we look at the relationship of the pieces that we have, we can start to make some statements. So let me give you one statement to begin with. That red trapezium covers half the area of the yellow hexagon. So we can refer to that as being half. The other way we could say is that the yellow hexagon, it'll take 2 of these red trapeziums to cover it. Let's go for the blue rhombus. We can see there that one blue rhombus covers 1/3 of the area of the total hexagon, as opposed to it takes 3 blue rhombuses to make the one yellow hexagon. So there's a 3-to-1 relationship. If we look at this piece here with our green triangles, you'll see that one triangle covers 1/6 of the area of the whole yellow hexagon, and altogether it will take 6 triangles to make one hexagon. So now let's just talk a little bit about the 6 times table, having used that. So we know if we have one yellow hexagon, we would have 6 green triangles fit on top of it. But if we have 2 yellow hexagons, how many green triangles would fit on top? Well, obviously it's 2 6s, so that's 2 6s are 12. What if we had 3 yellow hexagons sitting on top? Well, 3 yellow hexagons, 3 6s, so I get 18. What if I had 10 yellow hexagons? Well, 10 6s are 60. What if I had 100 yellow hexagons? Well, 100 6s are 600. You start to see how we can just do some simple things like multiplying using this material. But our real reason for doing it today is to play with the idea of fractions. And so remember, when we put 6 green triangles on the top, each single triangle was 1/6 of the area. So let's now take that a step further and just talk about some of the fraction language that develops as we play. So now I'm going to take you back to our sheet here, and you can have a bit of a look, and as I say, you can play with it a little bit later. So in this case here, we can see, of course, we don't always have to cover with the same piece. And in this example here, we've used 3 different pieces. Now, we could be doing addition of fractions. This represents 1 whole, okay? And we can say, well, 1/2, that's what the red piece is, plus, remember, the blue rhombus is 1/3, so 1/2 plus 1/3 plus 1/6 is another name for 1 whole. So we've just done some very simple adding of fractions. We added halves, thirds, and sixths. They're in the same family of fractions. This piece works very nicely for it. If we want to do things like halves, fourths, and eighths, we'd use coloured rods as our model. But these ones work really nicely in halves, thirds, and sixths. Let's have a look at another idea that's happening here. We should be able to see when we look at the blue pieces here, that 3 1/3, because that's 1/3, that's 1/3, that's another third. That's if this has an area of 1. 3/3 or 3 1/3 is the same as 1. Likewise, 6 sixths is the same as 1, and 2 halves is the same as 1. And so we're developing a lot of early fraction work just by doing this stuff with pattern blocks. So just a couple of reminders here, how we started this idea and how we built on the idea. So one, we started with a very simple cat picture, and we just covered it, and we found a notion of area that the larger the piece, the less it takes to cover. The smaller the piece, the more it takes to cover. So that's one point. The second point is that we then worked out that you can cover shapes or areas with different pieces. And then we formalized it a little bit when we went to the hexagon and talked about ways to cover the hexagon. Now, as you try doing that, you probably realize there are a bundle of different ways to cover this, at least 8 if you're including the original hexagon itself. So let's focus on now somewhere we use some slightly different pieces, and you'll start to see a few other things happen. So let's go back to the screen, and we'll have a look at what happens when we combine a couple of different options. So this time here, I've got this piece here, and I've got this piece here. So I've got the 2 blue rhombuses, and then I put the 2 triangles in there. And so now let's review our vocabulary. That is 1/3 of the area. So that's 2/3, and then I've got 2 sixths, or I could say 1/3 and 1/3, and 1/6 and 1/6 are also 1 whole. But you can also see they're sixths, that 2 sixths covers a 1/3. So we've got a thing called equivalent fractions going on here. So there's bundles of different things that we can do with simple bits of plastic, basically. So I just wanted everyone to get a bit of an idea that these are not just simple tools, that they can develop a lot of mathematics, all involved on us understanding the area. So when you've got children covering shapes with the pattern blocks, what they're doing is building an intuitive understanding of this idea of area and covering, and that will then help them later on with a tougher or harder topic like fractions that happens there. So we can play a lot more in that space, but that's not what our focus is today. There's a couple of other things I'd like to talk about a little bit. And sometimes what it is when we take a piece of equipment, we sort of think it may be limited. And so what I'd like to do is just talk a little bit about how just by adding one other piece of equipment, you can change it a little bit. Now, all I've done here, you'll be able to see on the screen, is there are some mirrors. I'll try not to sort of, right there in the mirrors, and there's a little bit of tape down the center. Now you can buy commercial products that do the same, and there's some very good ones around that you can put into a frame that would do that. But I'm just going to use 2 basic mirrors, and watch as I put them down on the paper, and you'll start to see some ideas coming out about the notion of reflection and, of course, rotation that sits in here. So I just want to put the 2 mirrors on here, and then we're going to slide some pieces in. You'll see it from above. It's going to be a little bit hard to see, but you can see it's got a hinge. Okay, so there are some materials such as Geoland, for example, would give you that sort of focus that would allow you to do it. Now, if in here I take a piece and I slide it right into that spot, you won't be able to see straight away, but I'll show you in a minute what's happening. We've squeezed this down around that piece, and if we were to turn it up, and this may or may not work terribly well, you will start to see, wow, look at that. You can start to see that there's one original and there's 5 images there. There's a lot of really nice mathematics that's sitting on inside that. A little bit hard to show on the screen, but I think you're getting the idea. Now, just like you think a little bit about what we've just done and develop some of the mathematics that sits from this idea. All we did was took the original pattern blocks. We added one other feature, which is some mirrors. Mirrors can be hinged or taped, but that allowed us to look at some other mathematics. So let me talk about the mathematics. We can now talk about the angle. So if we take that piece here, all right, and we push this piece as the one that we put into the mirrors, we can start working out what's that angle that is there. Well, I just want you to remember there was one original and 5 images. So that means there's 6 all at this point. Now, if you think about the angle in a circle, a whole circle, there's 360 degrees. When someone says they've done a 360 or they've been all the way around in a circle, and we've got 6 of those. So if we divide 360 by 6, we start to work out that that angle in there must be 60 degrees. Now, a lot of people don't quite realize, but there's an angle relationship between all the pieces of the pattern block. So if we put those 2 on there, you'll notice that 2 of these will fit into that angle. A little bit hard to see, but you'll sort of get the idea. So that means that small angle there must be 30 degrees because 2 of them fit in a 60-degree angle. And so we could start playing with all the angles. The obvious one to do is the square, because we know those angles will be 90 degrees. And you would find that 3 of these fit on top of that square into that corner. So that also proves that that is 30 degrees. So just something small and something short with the idea of pattern blocks. But I'd hate people to think that pattern blocks are all about just very simple mathematics. So when you start seeing older children using pattern blocks, you might say, oh, they're toys. You know, that's the baby stuff that they did. That's the geometry where they put in little patterns and so forth. So I'd just like to share one other idea. I want to take a fairly difficult concept in fractions and show you how it links back to everything that we've been doing in this webinar. Sometimes the teacher will say something to you about like, simplify this fraction. Well, simplify is a very difficult word in the sense. So I want to illustrate what it means when we use a word like simplify. So we're going to go back into all of the ideas that we've stitched together in this webinar. So remember the first one was we're going to take the shapes and we're going to talk about covering an area. So we just head you back down and we'll have a look at one example here. Okay. And so if you look on the screen, we're going to have the yellow hexagon, and what we will put together with it will be the blue rhombuses that we had before. So remember remember 3 of those fit on this. So if this has an area of 1, this would represent 1/3 of that area. And so we've got 2/3 and so forth, and 3/3 will give me 1. So the teacher says to you, I would like to do 3 lots or 3 times 2/3. Well, that's 1/3, so that must represent 2/3. Okay, so if we want 5 lots of 2/3, that's 1 lot of 2/3, and that's 2 lots of 2/3, and that's 3 lots of 2/3, and then this is 4 lots of 2/3. You can start to see that, you can see it building. Looks a little bit like those ducks that used to hang on people's walls once upon a time. But we've got 1 lot of 2/3, 2 lots, 3 lots, 4 lots, 5 lots. In other words, 5 times 2/3. Now, the word simplify means to make, or use, in this case, the least number of blocks as possible. So if you notice here, 5 lots of 2/3 would be equal to, well, there's 1. You can see it. There's 1, 2, and here's our second one, and 3. There it is. So we've got 1, 2, 3, and what's left over? 1/3. So when we say simplify 5 times 2/3, the answer is 1, 2, 3, and 1/3. And so sometimes when we've illustrated with the use of materials, it builds understanding. Now, just bear in mind that there's multiple steps to this. So just to summarize a little bit, what we've been doing in this webinar is giving a number of experiences. You notice when we've been giving those experiences of covering and so forth, that I've been very particular in the use of language, because what I want to do is build some experiences. Then I want to get the notion of what's the language that's going on. And then we're building a mental picture. So when we were talking about 1/3 there, we could visualize the 3 pieces sitting on that flat yellow hexagon. At the last bit, as children build from this, they'll get to things called symbols. So they'd actually write the equation that would do this. But it's good for us to build this understanding knowledge first. And that's really what manipulatives are designed for. And this one actually is a bit more than just covering some pictures. You start to see it's got quite a lot sitting inside it. If you think about it, we've done some geometry today. We've done some area. We've looked at angle. We play with some mirrors. And we've finished up at some pretty serious fraction work. We did adding of fractions, and now we've just done multiplying of fractions. So I just hope that's given people an idea of the versatility of this thing called a pattern block, and hopefully they'll be useful for people to use in the future.
Paul, thank you very much for today. We love the early geometry. I can definitely do that with my youngest child while the older one's doing fractions and taking it to multiplication as well. Yeah, I was just going to ask, is there a standard that you can put those shapes into every shape? Like every shape's always 8 and more?
Okay,
or is that not a standard?
Well, there's a couple of things here. A couple of the shapes won't fit onto the others. So, for example, the square, that's used for other purposes, but it was deliberately designed that way so that not every piece fits on, and neither does that piece. But I tell you what's very neat about this is you can start to get ideas about perimeter and area. So, for example, in here, you can see quite clearly that if you walk the pieces around each other, okay, the perimeter of this tan rhombus and the perimeter of this orange square are exactly the same. However, clearly the area is not the same. And many people have this misconception that somehow this perimeter is linked to the area. You can see the area of this piece is far less than the area of that one. So the pieces have a variety of different uses. I just used some of the pieces today to illustrate some of the key ideas that come up.
No, it was fantastic. And just to remind to everyone that the video will be available on both YouTube channels, so Dr. Paul Swan, YouTube and EDX Education, but also on the new website, the Math 101 or the mathmaterials.com website. And it's also going to have the PDF, so you can cut out your own pattern blocks if you don't have them. And I know that Dr. Paul Swan has a pattern block book and a lot of different resources on his website that you can actually go to. So thank you very much to the team, to Dr. Paul Swan and his team today, and we look forward to, I think it'll be the 3rd of August is the next one, and we'll let you know what it's going to be on.
Thank you. Thanks, Heather.
Thank you again.
Bye.
Thank you.